Okay, so the question is a capacitor with an initial potential voltage of 100 volts. Now I'm going to do 70 volts instead of 100. Is discharged through a resistor when a switch between them is closed at t equals 0. At t equals 10 seconds, the potential difference across the capacitor is 1 volt. What is the time constant of the circuit? All right, so we're going to use the exponential equation. So that is V is equal to V naught e to the minus t over RC. So that is this equation. V is equal to V naught e to the minus t over RC. Now, because it says initial potential voltage, that is V naught. So V naught, I know in the question it says 100, but we're going to do 70. So then you can try that 100 yourself. So V naught is equal to 70. So, and we know that t, what's t equal to? So t equals, when t equals 10, the potential difference across the capacitor is 1. So t equals 10 and V is equal to 1. So those are the values. So we're going to substitute it in. So then we have 1 equals 70 e to the minus t over RC. So we have 1 is equal to 70 e to the minus t over RC. We know that t equals 10, don't we? So 1 is equal to 70 e to the minus 10 over RC. So that is what I meant. So 1 is equal to 70 e to the minus 10 over RC. Now what do? You divide both sides by 70. So you divide both sides by 70. You bring the 70 to the left-hand side, and then you ln both sides. So ln 1 over 70 equals minus. So if you ln an exponential, it's just the power itself. Now on the calculator, you do ln 1 divided by 70. So ln 1 divided by 70 on the calculator, and you get minus 4.248. So I'm going to write down as minus 4.25. So you get that minus 4.25 equals minus 10 over RC. So rearrange to get what's RC, because what's RC? RC is the time constant. So minus 10 divided by minus 4.25. On the calculator, I'm just going to do minus 10 divided by answer, and you should get 2.35. All right, so let's just recap. So V is equal to V naught e to the minus t over RC. V naught is the initial voltage. So in this case, I'm going to use V naught as 70. Obviously, in the question, it will be 100. So t is equal to 10 seconds. And then V is equal to 1 when t equals 10. So substituting all that in, 1 is equal to 70, where 70 is V naught, e to the minus t over RC. And you know that t equals 10. Just put all these values in and then rearrange for RC, and we know that t is equal to RC, so the time constant is equal to RC, and then you should get 2.35 seconds. The unit is seconds. So RC is equal to 2.35 seconds. Now B, what is the potential difference across the capacitor when t equals 17 seconds? So now you know that t equals 2.35, you substitute it in. So you use the equation V equals V naught e to the minus t over RC. So again, you use that equation, but now you know that RC equals 2.35. So, and you know what the initial voltage is? The initial voltage is 70, but obviously the question is 100. So V is equal to 70 e to the minus we know that t equals 17 now, so it's 17 divided by 2.35. so the 2.35 was worked out in the previous part. You're given in the question t equals 17 and the initial voltage is 70, but obviously in the question is 100. I'm just doing 70 as an example, and then you just use the calculator, put that in. So on the calculator you do e to the minus 17 to the 2.35, so e to the minus 17 divided by 2.35, That is what I have. And then I am multiplying that by 70. And then your answer is 0.05. So V is equal to 0.05 volts. So your answer is V is equal to 0.05 volts. So that's the example where V0 is equal to 70 instead of 100. Okay, and the next part of the question, you have a 1.0 microfarad capacitor with an initial stored energy of 0.5 joules. Is discharged through a 1 mega ohm resistor. What is the initial charge on the capacitor? Now, on the right hand side, you're given E equals half QV. So 0.5, so you know that's the energy, 0.5, that's the energy, and it's equal to half QV. Now we don't have Q in the question. We don't have V in the question, but we do have C, and we want to work out Q. So we're going to use this equation here, the one at the bottom. So the equation is E is equal to Q squared over 2C. So we're going to use 0.5 is equal to Q squared over 2. Now what's C? C is 1 times 10 to the minus 6. So that is the equation that you have. So E is equal to Q squared over 2C. And you're given E because E is 0.5. I'm not doing the question for you, so it's 0.4. I'm going to do 0.4. So 0.4 is equal to Q squared over 2 times 1 times 10 to the minus 6. So you can rearrange to work out Q. So Q is equal to this. Well, you multiply 0.4 to 1 and 10 to the minus 6, and then you square root it. So you have 0.4 times 2 times 1 times 10 to the minus 6. And then you square root that, and then I get Q is equal to 8.94 times 10 to the minus 4 coulombs. So that is what I get. And so that's part A. What is the current through the resistor when the discharge starts? So you use V equals IR. You use V equals IR. What is R? Okay, so you know that Q is equal to 8.94 times 10 to the minus 4. You can use Q equals VC, couldn't you? So Q equals VC. So you use Q equals VC. You use Q that you worked out, you put it into there. And you know C in the question. C in the question is that. C in the question is this one here over here. And then you can work out V, couldn't you? So 8.94 times 10 to the minus 4 equals V times, you know, C is 1 times 10 to the minus 6. So 8.94 times 10 to the minus 4 is Q, which the one that we worked out earlier. You don't know V, and you know C is 1 times 10 to the minus 6. Do we know R? Yes, you do know R. R is 1 times 10 to the 6. Okay. So using V equals IR, you can say that I is equal to V divided by R. So from V equals IR, you know that I equals V over R. Here you can work out V, and you're given R in the question, so you can work out I. And then for part C, determine VC, the potential difference across the capacitor, as functions of time. So you need to use this, don't you? So V is equal to V naught e to the minus t over RC. So what is V naught? V naught would be the V naught that you worked out from here. But remember, I'm using 0.4 joules. You need to use 0.5. So V naught would be the answer to the answer to this one. but you need to use 0.5, and that's V naught. And then what's RC? Well, you know C is that one, don't you? You know C is this, and you know R is that. And because it's as function of time, that means time is a variable. So you can just leave it as t, and then you have to leave it as an expression. So you need to write an expression for that. So your answer then would be in the form of this, but you need to work out the value for V naught. You need to work out the value for RC, and t is a variable, and V is the, so like V is the Y.